Hi guys, this is Mrs. Allison. Today we are going to look at angles and radians, and you should have the note sheet in front of you called Angles and Radians. I'm actually going to break this into two different videos, mostly for time's sake, so it uploads a little bit quicker. And then that way it's a good natural break if you want to take a break in the middle of the two videos. One of the best things that you can do as you're taking notes while listening is make sure that you're drawing pictures. If you didn't understand something, pause the video, rewind it, listen to it again, and see if it'll start to make more sense as you go along. Okay, so we're just going to jump on in. All right, so we're going to start with our trig unit. And the reason I had you review special right triangles is because it's going to play very nicely into what we're going to be looking at for trig. Now, we're going to be looking at trig on the coordinate plane, meaning a set of axes, so an x and a y axis. Okay, and so everything that we're going to be doing today deals with the coordinate plane trigonometry. Now, today's going to be pretty definition heavy, meaning I'm going to give you a lot of words. And so the reason there's a big picture on the side is so that you can put a visualization to those words. I'm not going to necessarily quiz you on these definitions, just like any time. Really, it's when the word comes up, you know what's being talked about. And trig happens to be a pretty heavy thing on the ACT, not quite as heavy on the SAT, but these do come up. So, and going forward for pre-calc, this will be great skills for you to have. So here we go. An angle is in standard position when the initial side, we're going to call it, I don't know why none of my dots are showing up on initial. Okay, when the initial side is the positive x-axis. Okay, so an angle is in standard position when the initial side is the positive x-axis. Okay, what does that even mean? Well, to be able to explain it, we need to know what the initial side is. And we can see that the initial side of an angle is the side that doesn't move. When it's in standard position, it will be, and we just said this before, this will be the positive x-axis. Okay, so here's what that looks like. Let's talk about where the positive x-axis is. So the positive x-axis, if we know our coordinate system, we know this vertical part is the y-axis, the horizontal part is the x-axis, so the positive x-axis is from the origin going on to infinity. So I'm just going to draw in here my initial side, and I'm going to draw it, and I'm going to draw a line like this. So this is what we call my initial side. Now, if I had more room on this note, I would probably label it initial side, but I'm just going to put IS, even though. So that's my initial side. Okay. Well, we've got to have something else that goes with it. If we have an initial side, we have to have an ending side. Well, it's not called ending side, it's called terminal side. And the terminal side is the side of the angle that moves. So I'm going to draw a couple. So I could have a terminal side that looks like this. And so my angle would be the angle from the initial side to the terminal side. I may have a terminal side right here. In fact, this terminal side could move all the way around the circle, or the coordinate system, which would make a full circle. In fact, it could keep going. It could go multiple times around. So this is called the terminal side, and I'm going to call it TS just because I don't have any more room to write terminal side. And the angle that is created is the angle that we're talking about, the amount of spin that goes around. So let's talk about that. The measure of the angle is determined by the amount of rotation. Amount of rotation. Okay, so the measure of the angle is determined by the amount of rotation. Well, going along with that, a positive angle in standard position is generated by a counterclockwise rotation. I don't have much room to write in there. Counterclockwise rotation. That's getting worse. Let's see if I can clean that up a little bit. Counterclockwise rotation, meaning if I have a positive angle, it's going to start at the initial side and it's going to rotate in the counterclockwise direction. So this would be an example of a positive angle. I could even go further and I could have a positive angle that goes all the way around and comes back, and that's still a positive angle. So anytime a rotation is in the positive direction, meaning it is going counterclockwise, it's considered a positive angle. Okay, so similarly, a negative angle in standard position is generated by a clockwise rotation. A clockwise rotation. And what it looks like is it starts in this initial side and it rotates clockwise. And so this would be an example of a negative angle. Okay, so we have an initial side. That's the side that's on the positive x-axis. We have a terminal side. That's the side where the angle ends. We determine the measure of the angle based on how many times it goes around the circle or how far around the circle it goes. And we know it's positive if it moves counterclockwise and negative if it moves clockwise. Okay, questions so far? Feeling pretty good? If not, stop, rewind, pause, take a second, because we're going to move on. These next topics are going to be very important when it comes to using what we call the unit circle, which we'll do a little bit later. Okay, so the next type of angle that we're going to talk about is something called a coterminal angle. Well, what does the prefix co mean? Right, it means together with something. So when it says coterminal, it means it's together with the terminal side. So a coterminal angle are angles with the same initial and same terminal side. I'm glad that word terminal is in there twice. On your notes, it's not there twice. I just happened to type it twice on here. Whoops. Okay, so what does that mean? Well, I'm going to draw a picture for you, and it doesn't matter where the angle is, except that it needs to be in standard position. So here's my initial side, and I'm going to draw my terminal side. Let's just move it around. Let's call it right here. Okay, so if the angle that I'm looking at is this positive angle here, to be coterminal could mean it's the negative angle that ends in the same place, or it could be that it's the positive angle that goes around more than once. So coterminal shares the same, shares the same initial and the same terminal side. Just doesn't matter how many times it goes around. I mean, my angle could go around in this negative direction 22 times, and we're going to just trust me that this was close to 22, as long as it starts and ends in the same place. Those would be coterminal angles. So let's look at what that looks like when it comes to values of angles. Okay, if I want to sketch an angle in standard position, say 60 degrees, okay, I know my initial side starts here at this positive x-axis, and my terminal side needs to be about 60 degrees. Well, let's think about our quadrant or our coordinate system. It works really well because it's divided into quadrants. How many degrees is it between the positive x-axis and the positive y-axis? 90 degrees. So that works out nicely because if we know those reference points, this is 90, this is 180, this would be 270, and all the way around would be 360. To get my terminal side of 60, I know it's going to be about 2/3 of the way through that whole angle. So a positive 60-degree angle, and it's positive, so I'm going to just draw it right here. There's positive 60 degrees. To be coterminal to that, if it's in the positive direction, means that it needs to not just be 60 degrees, but it needs to go around once and come back. Well, how many degrees would that be? Well, if I went a full circle which is 360 degrees, and then the 60, a positive coterminal angle with 60 degrees would be 420. Okay, well, what about a negative coterminal angle? Is there such a thing? Meaning, could I start at my initial side and go around and find a negative angle that ends at the same place? Well, sure. Well, how big is that angle? Well, think about it. If a full rotation around the circle is 360 degrees, and I know that angle is 60, then this is 60 less than a full rotation. So my negative coterminal angle would be negative 300 degrees. How do you feel about that? Okay, here's what I'd like you to do. Pause the video and try the next example. See if you can do the next example on your own. See if you can sketch the angle in standard position and see if you can find a positive and a negative coterminal angle. Okay, so theoretically, you've taken time to draw your negative 120. Now it's negative, so positive 120 would be going in the counterclockwise motion, but negative 120 needs to come this way. And if I know this is 90 and this is 180, I'm less than 180 degrees would be 120. In fact, but I'm just a little bit more than the negative 90. So I'm going to draw my negative 120 somewhere, oops, I didn't quite hit the axis, somewhere right about here. Okay, so I'm going to call this angle right here negative 120 degrees. Now, do you have to draw a picture to find coterminal angles? No, you don't. I'm a visual person. I like to see the pictures, which is why I draw them, because then it helps me to visualize what would be coterminal to that. So let's start with the positive. If it's going to be a positive coterminal angle, my starting and my ending, my initial and my terminal side haven't changed. I just need to go in a different direction. So how many degrees is this? If the negative is negative 120, positive would be more than 180, but less than 270. Okay? More than 180, but less than 270. Well, that's going to give me 240 degrees. Why? Because 240 plus a positive 120 would give me a full circle, a full rotation. So my positive coterminal angle is 240 degrees. What about a negative coterminal angle? Well, right, I've got to go around the circle more than once. So one time around and then back to the 120 gives me a negative coterminal angle of 480. Okay, what you'll notice is that each time, for example, with the 60, to get a positive coterminal angle, I can add 360. 360 plus 60 is 420. 60 minus 360 is negative 300. Now it's a little bit different here. If I'm going to do negative 120 and I add 360, do I get 240? Yeah. But negative 120, I'd have to subtract 360 again, which gives me a negative 480. It's even bigger than that. So these are my positive and negative coterminal angles. Okay, so if you need a break, pause, rewind the video, watch coterminal angles again. Basically, they share the same ending side, same starting side too. But okay, let's move on. All right, now we have something called a reference angle. And right now, dealing with a reference angle isn't going to seem, you may not quite understand why we do it, but eventually when we get to the unit circle, you'll understand the idea of reference angles really well, why we use them. Well, let's get a definition for what a reference angle is. A reference angle is it measures the closest distance from the terminal side to the x-axis. Okay, so which one is our, whoopsies, I should probably spell that correctly. Which one is our x-axis? Well, our x-axis is this horizontal axis. So we're measuring the closest distance from the terminal side to the x-axis, meaning the closest distance is going to have to be between 0 degrees and 90 degrees. I can't be bigger than 90 degrees because then it's not the closest angle. We'll look at an example in just coming up. Okay, so I'm going to draw an angle of 130. Oops. So I'm going to start with the initial side on the positive x-axis. And 130 degrees is more than 90 by 40, but less than 180 by 50. So it's almost in the middle, but not quite in the middle of this. So I'm just going to draw it something like that. So we'll call that 130. Okay. Now, I know that positive 130 is this angle here. My reference angle is the angle to the closest x-axis. Well, this is my x-axis right here. So which part of the angle is actually closest to the x-axis? Well, it's not this green angle that I've already drawn. The part that's closest to the x-axis is this part right here. Okay, well, how big is that? Okay, so let's think about it. From this positive x-axis all the way around to the negative x-axis is how many degrees? Right, 180. So 180 degrees, but I've already taken up 130 of it to get to the terminal side. How many are left to get back to the x-axis? Right, 50 degrees. So my my reference angle is 50 degrees. Okay, let's look at another one. I'm going to try one of the negative ones, and then I'm going to have you try the positive, one positive and one negative on your own. So let's look at negative 60. Okay, so I'm going to draw my positive x-axis here, and negative 60 is not quite to 90. It's like 2/3 of the way through. So this is my negative 60 degrees. Okay, well, what angle is closest to the x-axis? Now notice it is always positive because it says that the angle will be between 0 and 90. And if it's going to be between 0 and 90, this means it's always going to be positive. Okay, that's important. So what is my reference angle? Well, guess what? My reference angle is the angle from the terminal side back. It's the exact same angle, except that it's not negative. So my reference angle here is 60 degrees. Okay, pause the video. Try finding the reference angle for 260 and then the reference angle for negative 312. Okay, so theoretically you've gone through and you've found the reference angles. So let's draw this. If I draw my initial side here, 260, and then I think about my terminal side. Well, I know that to this angle is 90, to this this axis is 90, to this axis would be 180, and then down here would be 270s, so I'm not quite to 270s, but I'm really close. So here's my angle. Okay, and it's the positive angle, so it's this direction. Okay, where is the closest distance to the x-axis? Well, hopefully you said from this angle back up here to the x-axis. Well, how big is that? Well, if my axis is 180 degrees, then the difference between 180 and 260 is 80 degrees. So my reference angle here is 80 degrees. How'd you do? Okay, let's look at the negative one. Let's start with drawing my positive, or my initial side, now my terminal side. Well, this is a negative 312, so I'm going in the clockwise rotation. All the way around would be 360, so I'm not quite there. To this axis would be 270, so I'm somewhere in the middle there. So I'm going to draw my negative side somewhere about here. And the negative angle that I just talked about was this one, negative 312. And again, you could do all of these without drawing a picture, but I'm such a visual person. I really like the visualization of where these angles are and what it looks like. Okay, so which one's my reference angle? Well, my reference angle is the distance between the initial side and the terminal side. It happens to actually be my coterminal angle, my positive coterminal angle. But it's this distance right here. Well, what is that distance? Hopefully, you got that it was 48. So you'll notice that my reference angles are always less than 90, but more than 0, meaning they're always positive. So these are my reference angles. Okay, so now's a good time to take a break. You could certainly try the assignment that's just labeled angles, or just do the questions relating to the angles. And the next video that we do, we will get to radians. So I'll talk to you in the next video.